Welcome to a lesson with Dr. Pal. Let's look at the last example that we had of an application problem and look at other ways that it might be asked or that it can be done. Perhaps we have X being the number of years. Then naturally you can think, how do you get T from X? We just divide X by 12, right? Take the number of years, divide it by 12 to see how many chunks of 12 you have. So you can just replace this t with x over 12. That's the first thing to recognize. Now, sometimes questions are worded in such a way where they want your base not to be anything but e. That's just common oftentimes. E is very nice for calculus and other things if things are written in terms of base e. So the question is, how can you write this in terms of base e? Well, simply all you have to do is rewrite your 1/2 in terms of e. So you say 1/2 is going to be e to some power. What power will this be? Well, you can think about this in two ways. One way of thinking about it is, well, e has an inverse. And so if we simply put the inverse inside of it, whatever we put here would be what comes out. What we want to come out is a 1/2, so we may as well just put a 1/2 right in here. Voila. This guy right here happens to be your k value that you're after. That's one way of doing it. Or you can just simply think, let's solve this equation. 1/2 is equal to e to the k. Take a natural log of both sides. Natural log of 1/2 is equal to, now wait a minute, we take a natural log of e to the k. What happens to natural log in e? Well, natural log comes up to e and say, I don't like what you did to that k, so I'm going to put k back out. And then you're just left with k. So you have natural log of a 1/2 is equal to k as expected. So what we have here, if that's the case, if they want you to write it in terms of e, that's all you need to do. Say f of t is equal to 2 multiplied by, then you simply, let's go down here and use an x actually. Why don't we do it in terms of x? It's more standard to do it in terms of number of years. And so then just replace your 1/2 with e to the natural log of a 1/2 x, and that's all raised to the x over 12. Now let's work with how to simplify this. Let's look at that natural log of a 1/2. We can just plug it into a calculator, and we get negative 0.693 for that natural log. Okay, so negative 0.693 approximately. I mean, this is approximate. As soon as you made an approximation, you better put an approximation symbol here, so it's not a lie. I mean, well, yeah, you get the idea. So, because it's only approximate when you round. So 2 times, and this is e to this, but then what happens here? You multiply these exponents together. So it's this multiplied 2. And if you want, you can separate this x over 12 as 1/12 times x. Now you just multiply those together and you get approximately negative 0.058 in the exponent. So it's about 2 times e to the negative, see, 0 point, and just look again. Negative 0.058 t, and we're done. So if a question asked you to find that value of k, I mean, there's a myriad of ways you could do this. This is just one way of doing this. I'll show you another way in the next video. Maybe you like that better. But also, it's kind of very intuitive and helps you think about it in different ways, so you can wrap your mind around what to do in different situations that may occur. Here, though, this value right here is maybe the k value they're looking for. Notice that this k value in a question, they might actually want this to be your k instead of that being your k. They might just want pure out the function is something times e to something times t. Maybe they want to know what that is. And here we've just found it. Notice that it's negative. When it's negative, that means there's been a horizontal reflection. So instead of going like this, it's going like that, which means it's decay. So it's decaying. Um, and so you get decay if this value is negative, you get growth if this value is positive. Kind of what they're doing when they're making everything base E in some senses is kind of giving you a number that you can easily detect by whether it's growth or decay and how much and so forth. And there's other purposes for it too, which we won't go into. Thanks for watching.